right, so here we're going to get a look at some of these functions, their names, their graphs, and we're going to take a look at the max number of x-intercepts, how many times it crosses the x-axis here, and we're also going to take a look at the number of times it makes a turn. So like if I have something like this, it would have 1 turn, 2 turns, all right? So for the first one, we've got f of x equals x, and this is called a linear function, right? We know, better off, we know y equals mx plus b, right? That's my linear function. But in this case, m is 1 and b is 0. So what this would look like is just a straight line through the origin here, right? Got a slope of 1, y-intercept is 0. There is 1 intercept, and there are no turns. Now, this is the max number of x-intercepts. There doesn't have to be this many intercepts for some of these. There does for a linear function, but you'll see later on what we're talking about here. So if we've got x squared minus 3, we know this is called quadratic. Should make a parabola. And so when we draw this, we could have a shape that looks like this. All right, and when I'm actually graphing these, I'm really just going to Desmos. I'm typing them in on Desmos, and then this is the picture I get. So make sure that your pictures here match my pictures, because my pictures are based on the equations that I've made for you here. All right. So when I graph this, I do get this, and we notice that there are 1, 2 x-intercepts. Now, not all quadratics have 2 x-intercepts, right? We've done problems where maybe we had a graph that only has imaginary solutions, right, like this. So when we talk about max number of x-intercepts, that's the maximum possible. It doesn't mean that we're required to have that many x-intercepts. You could have graphs that have 1 or 0. It just depends on the problem. All right, so it's just something to think about. Next up, we want to look at the max number of turns. For a quadratic, the max number of turns is 1. It's going to make a turn right there, right? It goes from decreasing to increasing. All right, then we've got our cubic function. It's cubic because we got x to the 3rd power, so that's the highest degree, therefore it's cubic. And this function is going to do something like this. Again, I just went onto Desmos and graphed this, and we can see the max number of times it touches is 3, and it has 2 turns, right? It turns right here from increasing to decreasing, and it turns down there at that local minimum, goes from decreasing to increasing again. So we got 2 turns. Whoops, 3 and 2. All right, we've got a quartic up next, quartic. And a quartic function, the one that I graphed on Desmos, looks something like this. All right, so give that a shot. And there are 1, 2, 3, 4 x-intercepts, and we have 3 turns. You've probably noticed a pattern by now with the relationship between the max number of x-intercepts and the max number of turns. And then the last one is called quintic. And what this one looks like is this one goes like this, just like that. All right, we've got 1, 2, 3, 4, 5 x-intercepts, and it turns 4 times. So what things do we notice? Well, what we should notice is that the degree of the polynomial, right, for example, if I've got a quintic function, my highest degree is 5, right, so this is a degree 5 polynomial. The degree of the polynomial equals the number of max turns, the max x-intercepts, right? If I have a polynomial that's degree 5, there are 5 possible x-intercepts. If I have degree 4, there are a max of 4 x-intercepts. If I have a degree of 3, there are a max of 3 x-intercepts, right? So if you just look at the degree of the polynomial, that should tell you the max number of x-intercepts you can have. And then we know that if we look at the degree of the polynomial, and we subtract 1 from it, that's going to equal the number of max turns, right? If you look at that last column, you'll always see that that last column is one less than the number of max x-intercepts, right? Minus 1, minus 1, minus 1. So the number of turns is always just one less there. All right, and that's something that we should notice about these polynomial functions. Now again, not all of these have to have this requirement, right? You could have a quintic function that does something like this. Maybe it only crosses once. That could be a scenario. When we talk about max possibilities, we're not talking about it always has to be this. We're just talking about the maximum possible number of times, right? It doesn't always have to be this much.